Welcome back, students, with another lecture. In this lesson, we will discuss a new chapter, Dual Nature of Radiation and Matter. Now we know an atom. The atom consists of a central nucleus. Around the nucleus, we have an electron revolving around the nucleus. Now, the outermost electrons are generally loosely bound. That means they are or they can be easily removed when they are under influence of high energy. So we will call these electrons as free electrons. Now, let us consider a metal surface. As we know, the metal surface has large amount of this loosely bound electrons, which are your free electrons, as shown here. All the metals, they are lying on the outside border of the metal surface, and they all contain your free electrons. Now, when a light of sufficient energy falls on the metal surface, these free electrons are ejected from the metal surface. So here we come across a term known as your work function. So what is a work function? The minimum amount of energy required by an electron to escape from the metal surface. So what we have noticed is that when a light of sufficient energy falls on the metal surface, these free electrons are emitted from the metal surface. Now your work function are measured in electron volt. So what is 1 electron volt? 1 electron volt is the kinetic energy gained by the electron when it is accelerated through a potential difference of 1 volt. Now, the energy gained by the electron equals to the work done by the electric. Now we know the work done by the electric field is Q times V, where Q is the charge of the electron, V is the potential difference applied to that electron. Therefore, my 1 electron volt will be charged 1.6 times 10 to the power minus 19 coulombs times the potential difference applied, which is 1 volts. So 1 electron volts equals to 1.6 times 10 to the power minus 19 joules. Joules is the amount or the unit of the energy. Therefore, 1 electron volt is the kinetic energy gained by the electron when it is under the influence of 1 potential difference or 1 volt potential difference. Now note, all the metals don't have the same work function. That means all the electrons in the different metals cannot be ejected with the same amount of energy. All the metals require different amount of energy to eject the electrons. Like in our case of cesium, the work function is 2.14 electron volts, potassium 2.3 electron volts, sodium 2.75 electron volts, and so on. So different metals have different work function, and all these work functions are measured in electron volt. Now there are different ways of removing an electron. Now if we remove electron by heat, then it is known as thermionic emission, where the metal surface is under the influence of very high temperature and the electrons are emitted. Such emissions are known as your thermionic emission. When the second phenomenon is your light, when your metal surface is under the influence of high energy or a high frequency light, what happens? The electrons are emitted. Such emission are known as your photoelectric emission. Now the third type is when your metal surface is under the influence of very high or electric field of high strength. In that case, such kind of emission are known as your field emission. Now note, whatever be the process of the electron emission, the energy required will always be equal to the work function. Fine. So here, out of these three methods, we will concentrate on our light emission or your photoelectric emission. So photoelectric effect. Now, in our photoelectric effect, we have a light source. This light source produces the light radiation. Now this light radiation falls on the metal surface. This metal surface are photosensitive material and they act as your cathode. Now the electrons emitted by the photosensitive material are collected by this detector, or they are detected by this detector. This detector acts as your collector and is the anode of the circuit. Now this detector in turn is connected to your battery, and battery is connected to your ammeter. Now we need an ammeter in order to determine whether there is a current flow through the circuit or not. Now note, in order to current flow through the circuit, we need a complete circuit. But in our case, we have a cathode and an anode placed in an evacuated glass tube. That means there is nothing between this plate, there is vacuum. Fine. Now in order for the current or for the electrons to flow through the circuit, there has to be a medium, or there has to be a flow of electrons. Now we will see how the electrons flow through the circuit, or I'll say let us see how the current flows through the circuit. Now let us consider your light radiation produced by the light source falls on the metal surface. Now this metal surface ejects electrons which are detected by your detector. Now this detector produces electrons which flows through your battery. Now if there is a flow of electrons through the circuit, that means there is a current flowing through the circuit. Now if current flows through the circuit, means ammeter will detect some current. Fine. So as the electrons flow, currents can be measured by your ammeter as shown. Therefore, by the method of photoelectric emission, the current can flow through a circuit. So what is a photoelectric emission? The phenomenon of emission of electrons from metal surface when electromagnetic radiation of sufficiently high frequency are incident on it. It's called photoelectric effect. Now, the photo-generated electrons, or I'll say the light-generated electrons, are called photoelectrons. So, based on this topic, you can take these questions as your homework. Define work function, give the unit of work function. Your second question, define photoelectric effect. So that's it for today's class. Thank you. And if you have any confusion, please feel free to ask. I will re-explain it to you again. So thank you.